Hello everyone, this is Mrs. Correa here with our area of two figures review. Our first couple problems, the instructions say state the most specific name for each figure. So we know that both of these are quadrilaterals because they have four sides, but there is a more specific name for each of them, and we need to look at the notations here. These little triangles tell us that these two lines are parallel, but these two lines are not. So a shape with one set of parallel lines is a trapezoid. Number two, we have two sets of parallel lines, one on top and on the sides. So we know that it is a parallelogram. A more specific name for a shape with two sides could be a rectangle, but we know this is not a rectangle because these angles are not right angles. So these angles have to be 90 degrees, but since they're slanted and not marked as right angles, we know that it is not a rectangle, it is just a parallelogram. All right, moving on to our next set of problems here. They want us to find the area of each. So let's start with number 3. This is a rectangle, and we know that the formula for the area of a rectangle is base times height. In order to solve this, our next step is to replace the variables with the numbers they represent. So our base is 6.9, and our height is 2.4. So we're going to do 6.9 times 2.4. And you're going to get 16.56. Don't forget to label your answer inches. And because we found the area, that's a two-dimensional space, so we need to say inches squared. So the area of the rectangle, 16.56 inches squared. Let's do number 4. This is a parallelogram. And the formula for the area of a parallelogram is the same as the formula for the area of a rectangle. Area equals base times height. Step 2 is going to be replace the variables with the numbers they represent. So instead of a base, I'm going to write 5.9, and my height is 4. Now, remember, if you're given a shape that has more than two numbers, like that could be more than two numbers labeled on this parallelogram, you only need two of them. You need the base and the height. So look for this right angle here. It will point to your two numbers. So this little right angle points to the 4 and it points to the 5.9. So it does not matter if this is labeled and this is labeled and this is labeled. All you need are these two numbers. All right, so the area of this parallelogram, we're going to do 5.9 times 4, and that's going to give us 23.6 inches squared is our label. All right, moving on to number 5. This is a triangle. In order to find the area of a triangle, our formula is A equals 1/2 BH. You could also write it as base times height divided by 2, whatever you prefer. It means the same thing. All right, let's replace our variables with the numbers they represent. In order to find your base and height, remember, look for that right angle. There are only two numbers in this problem labeled for us. However, there always could be more, right? There's 3 sides that could be labeled here. You only need the base and the height. So we've got 7 and 6.6. So I'm going to do 7 times 6.6, and then I'm going to divide by 2. All right, so 7 times 6.6 is 46.2. And then we're going to divide that by 2, and we're going to get 23.1 yards squared for the area of this triangle. Moving on to number 6. All right. Once again, our formula is area equals 1/2 base times height. All right, we're going to multiply our base and our height, and then we're going to divide by 2. Our base is 3, our height is 2.8. 3 times 2.8 is 8.4. We're going to divide that by 2, and our final answer is 4.2 meters squared. The area of the triangle equals 4.2 meters squared. All right, let's go to the back of the page. Number 7. This is a trapezoid. We have one set of parallel lines. We have 2 bases and a height. The formula for the area of a trapezoid is 1/2 base 1 plus base 2. So we're going to add the bases times the height. So our process is adding the 2 bases, multiplying times the height, and then dividing by 2. Let's start by replacing all of these variables with the numbers they represent. All right, our 2 bases are 1.8 and 7. So we're going to do 1.8 plus 7, and then times the height of 5.4. And then we're going to divide by 2. So 1.8 plus 7 is 8.8. Next, we're going to do 8.8 times 5.4, sorry. 0.8 times 5.4 is 47.52. And we need 1/2 of that, so we're going to divide by 2 to give us 23.76 kilometers squared. That's the area of this trapezoid. All right, moving on to number 8. Okay, also a trapezoid. I'm going to write down the trapezoid formula. All right, we're going to add the 2 bases. Our 2 bases are the 2 parallel lines, so 4.1 and 10.9. Sometimes when this problem is given to you, there are numbers all the way around. You don't need all of the numbers. You only need the 2 bases, and those 2 bases are separated by the height. Okay, so this right angle once again shows us where our 2 bases are. Okay, ignore all of the extra numbers if they give them to you. All right, so we're going to start with 4.1 plus 10.9 times the height of 5, and then we're going to divide by 2. All right, let's start with inside the parentheses. 4.1 plus 10.9 gives us 15. All right, next we're going to multiply 15 times 5, and that gives us 75. And our last step is to find half of that. So we're going to do 75 divided by 2, and that gives us 37.5 centimeters squared. And that is the area of this trapezoid. All right, moving on to the circles. Number 9. All right. Now, our formula for the area of a circle is pi times the radius squared. Remember, the radius is halfway across the circle. It's the distance from the center of the circle to the edge of the circle. So in this problem, they gave us the radius. So let's go ahead and label r equals 4.5. And that becomes important when we find the area of our circle over here. Let's replace these symbols with the values they represent. So we know that pi is 3.14, and we know r is 4.5, and that is radius squared, so we need to do 4.5 squared. Okay, now that means we're multiplying 4.5 times itself. So 4.5 times 4.5 is 20.25. Now we're going to multiply 20.25 times 3.14, and that gives us 63.585. I'm just going to write 63.6. meters squared, just rounded to the nearest tenth. All right, let's look at number 10. Now notice number 10 looks a little different than number 9. Before I zoom in here, notice this distance goes all the way across the circle, where this distance only went halfway across the circle. So this was the radius. They didn't give us the radius here. Here they gave us the diameter. So in order to find the area of the circle, the first thing we're going to do is we're going to divide this diameter by 2. So zooming in here, we need halfway across the circle. So 30.2 divided by 2 is going to give me 15.1. So 15.1 is my radius that I'm going to use when finding the area of the circle. All right, my formula, pi times the radius squared. We're going to replace these symbols with the numbers they represent. So pi is 3.14, and the radius we know is 15.1, and its radius squared. So we're going to do 15.1 times itself. Don't do times 2. That's really tempting, but don't do it. We're going to do 15.1 times itself, and that gives us 228.01. We're going to do that times 3.14. And that gives us 715.9514, but I'm just going to round to the nearest tenth. So 715.9 centimeters squared. That is the area of my circle. All right, last 2 questions. We have a composite figure here, which means that it is one figure made out of more than one shape. I see 2 shapes here. Let's go ahead and name them. I see a semicircle and a triangle. So I'm going to write this out here. Semicircle and a triangle. All right, let's start with a semicircle. Writing down the formula. A semicircle is half of a full circle, so I can go ahead and write down the formula for a full circle, but then we're just going to divide that by 2, and that's going to give us our semicircle. All right, now the formula for a triangle, go ahead and write that down, we know is base times height divided by 2. All right, and then once we're done, we're going to add these together. So we're going to find the area of the semicircle, the area of the triangle, and then we're going to add them together. All right, so for the semicircle, we've got pi times the radius squared. We know pi is 3.14. And they gave us the radius. The distance from the center of the circle to the edge of the circle is 8 centimeters. So I'm going to do 8 squared times 3.14, and then we're going to divide by 2 to find half the distance. All right, so start with the exponents. 8 times 8 is 64. And then we're going to do that times 3.14, and then we're going to divide by 2. So 64 times 3.14 gives me 200.96. And then my last step is to divide that by 2, and that's going to give me 100.48 centimeters squared for the area of my semicircle. All right, let's do the triangle. So we've got base times height divided by 2. The base and the height of our triangle can be found by looking at this right angle here. We're going to look to the both directions. So our base is 24, and then our height is this distance here, which is actually the diameter of the circle. Remember, this 8 only goes from the center to the edge, so only half of the distance we need is 8. Which means the other half of this distance is also 8. So altogether, what is the height of this triangle? It's 16. 8 plus 8 is 16. So when we go ahead and replace our values in our triangle formula, we're going to do 24 times 16 divided by 2. 24 times 16 is 384. 384 divided by 2 is 192 centimeters squared for the area of our triangle. Now we're not done yet, because they want the whole figure, not these two shapes separately. So in order to find the whole figure, we have to add these together. So we're going to do 100.48 plus 192. And that's going to give us our final answer of 292.48 centimeters squared. And that is the area of this figure. All right, let's look at our very last problem on our review. All right, this is yet again a composite figure, so we have two different shapes here that we're going to add together. So the two shapes that I see are a rectangle and a semicircle. And once we find the area of these two, we're going to add them together. So let's write in our formulas. The formula for a rectangle is area equals base times height. And the formula for a semicircle is the formula for a whole circle, pi r squared, and then divided by 2. All right, so let's look at our rectangle, replacing those variables with the numbers they represent. So our base is 8, and our height is 6. So 8 times 6 is 48 yards squared. It's the area of the rectangle. Moving on to the semicircle, we know that pi is 3.14, and the radius, which we know is the distance from the center of the circle to the edge of the circle, is 3 yards. So I'm going to do, instead of r squared, I'm going to write 3 squared, and then we're done. We're going to divide by 2. All right, let's focus on that exponent. 3 times 3 is 9. So rewriting this, I've got 3.14 times 9 divided by 2. All right, I'm going to do my multiplication. 3.14 times 9 is 28.26 divided by 2. And then final step, 28.26 divided by 2 is 14.13 yards squared. All right, so we've now found the area of the rectangle and the area of the semicircle, and we get to add them together. So let's do 48 plus 14.13, and that's going to give us our final answer of 62.13 yards squared, and that is the area of this figure. All right, rewatch this video if you need to. Let me know if you have any questions.